Hello again, everybody, and let's again continue our discussion on functions and modules. So now we've kind of covered functions, and so now we're going to go into modules. So if you want to think about it, um, how do functions and modules relate to each other? You can think of like almost like a module, maybe as like a folder. Well, that's not a good analogy, but modules modules contain modules are files that contain functions. And so we can think of we've used modules before. We've looked at some. We've looked at the math module, and the math module contains functions that are related to mathematical operations, right? Um, if you can think of another module, let me think of another module off the top of my head. There's several modules. There's a module for graphical user interfaces, and so that module will have functions that are associated with building graphical user interfaces, and I hope we get to use that at some point. So actually, let's just maybe even do a little bit of our own research, and let's see. Uh, Let me look for something that I know. Tinctor. Okay, so this is a package. So Tinctor package is a standard Python interface to the TK GUI toolkit. So let's see. Um, Tinctor modules. Okay, so there's some modules associated with the Tinctor package. So now we have another hierarchy. We have packages that contain modules, and modules contain functions. So support for Tinctor is spread across several modules. Most applications will need the main Tinctor module as well as the Tinctor.ttk module. Okay, let's look at that. So this module provides access to the TK themed widget set. Okay, so this is telling us how to use the module. So this is something we're going to be talking about. Import statements, right? So you can imagine that we write we can write modules that represent different functionalities, but then how do we want what makes it powerful is that we can reuse it in different applications in different programs, right? And we can do that by just using an import statement. And this, I believe this comes with this with the Python standard library that you guys are all have all downloaded. But sometimes you do some research, as a developer, and you see somebody actually made their own package, which has a set of modules that are useful to you, and so you would download them, and then, you know, there's a whole nother process with that. Okay, so yeah, so this is a module, and it's telling us some common use cases, options. Let's see what if we can see the functions here. Okay, let's see. Here's a function. So here's a get function. It says return the current value of the spin box set. So yeah. So without going into so here's some more functions: add, forget, hide, identify, index, insert, select, tabs. Okay. So that's just a module in the wild, if so to speak. But we may get exposure to some of the modules that are in the standard library. Okay, so but we want to create our own, right? So how to create user defined modules, which is like modules that we've created by ourselves, us being the user. So we have worked with a couple different built-in modules so far. Random being one, remember, and then also math. So these two modules are just ordinary, everyday Python files. They are in reality two Python text files in a directory somewhere that your interpreter can use, called random.py and math.py. All of the functions that we have been using are contained inside the file random.py. So if you guys use like randint and some other stuff. So when we use the import statement in our programs, these functions are put into memory and are now accessible to our program to use. User-defined modules. It turns out that there is really nothing special about random.py and math.py. They are just Python programs. Any text file that contains Python code can be imported as a module. This means that any program that you have written so far this year could be imported as a module, which means that all of the functions in the imported program could be used in your new program for free. Let's see an example. So here's an example. So consider the following program saved to a file called factors.py with the following code. So we have remember the code find factors. So what is the program's output? Well, the program's output is a list of the factors of the number. And so we have a main function here, remember that, and we're printing out find factors of the number 72. And then here we're running the program by calling main. And so, yes, this program would print out all of the factors of 72. And so this is the example continued, right? Um, so on the so here's the so here notice here at the top, this is just the file name factors.py. Now we have a new file called myprogram.py, and we want to use this function. Right now we could copy and paste it in here, but it's even much more powerful and useful if we can just import. We can import all of it with an import statement like this. So from factors import star. What does this mean? So it says from factors. So it's going to look for factors in your directory, it finds it. And then it says import star. Import star means import everything that's in that file. And so now we utilize it. We say for num in range. So we do another loop, and then we want to find we want to find the factors of the number. So what should be the output of this my program.py? Try it. What do you think is happening here? So this is a good exercise for you all. So try it yourselves. So example continued. The problem is that when you import factors.py, the main program at the bottom is also executed. Normally, when a module is imported, we want to use all of the functions in the module, but we do not want to execute any of the code in the main program of the module. To prevent the code in the main program, so remember, we don't want to execute. We don't want to really. This is not useful to us. All we want is this function. We don't want to run the main function because the main function is really about testing the code. So to prevent the code in the main program from being executed, programs that are imported as modules often use the following code at the very beginning of the main program. And so here we just have a simple if statement. If, and this is a special variable because it has double underscores before and after. So this is like this has a specific meaning in Python. So we say if name underscore name underscore is equal to underscore main underscore, right? So in here we have it here. We say if this is true, then run main. Okay. So and then we use this and then it should be working as intended, right? So it says now rerun both programs and it should be working as intended. Okay. So let's add some debug code to the two files to see what's really going on. So underscore name underscore is a built-in variable that is set when the program starts. If the program is running, so you don't see that happening. This is all taken care of behind closed doors, so to speak. As long as we understand what's happening and how to utilize it, right? That's what's important. So if the program is running as a script, not as a module, so What's the difference? So if it's running as a script, not as a module. So here we're using factors as a module, but here it's being used as a script. So that's the difference. Um, so let me go again. So if it is running as a script, then the variable, this special built-in variable, has the value of main. In that case, the test code is executed, right? Because in that case, we execute what's inside the body of this if statement. Otherwise, if the module is being imported, the test code is skipped. So here it's actually being imported. So everything that's in this file runs, well, works, except this. So accept this part. Okay. Yes. So going forward, so typically we will not be taking just any program and importing it as a module into other programs like we just did. However, it is good to know that it can be done and how to work around the execution of the main program that you are importing. You should be aware that regardless of how trivial a script or program is, many programmers will always use this line in their programs just in case. So going forward, typically in this course, when we create a module, it is expected to be a Python program that contains several functions that are somehow related to each other. So think about the math and random modules. Contains a main function that holds all of the tests for the functions contained inside the module. The main program will always contain these two lines only. Yes. So the main program will always contain these two lines only. Only these two lines for the main program. So we previously wrote two functions called SumEven and SumOdd. Create a module called SumUtilities.py with just these two functions. So the file is called SumUtilities.py, and then we just put in these. We put in these functions in here. We have a main function, and then we just want, and we inside the main function we can just put up whatever, however we want to test these functions. We want to put tests there, and then here's how we run it, right, in the main program, and we just write this line. So functions can contain inside the module that will be available to other programs to use once SumUtilities is imported. The main function is for a module is different than for a regular script. Its purpose is to contain tests for the functions in the module. The main program for a module will always contain just these two lines only. So our first real module. So we can imagine that, so we can call this module mathutilities.py, and we can imagine that we can put all these functions in here, right? You do not need to write the main function or any of the other tests for these functions. You do not need to write the main program either. Just collect all these functions into the module for later use. So you don't necessarily need to write a main function here if it's a module that's just going to be used for for other files. hmm And so you can create a module with all these functions called mathutilities.py. So let's okay, actually let's just show an example so you have a working example of what that actually looks like in say VS Code. Okay, so unit 2. I'm going to create the file math utilities.py. Okay, and um so I'll just write a comment. I'll write a doc string. this module contains the following utilities for math operations. Well, I don't want to number it. I just want to be simple. Some even. Some odd. Find factors. Factorial. And was it is prime? Is even. Okay, so I'll just put in there's a few. So I'll just put in these two. Okay. And save that. And I can add in the others later if I want. But this is what this is just what it would look like. And then if I want to utilize this, so now let me just create a new file called practicing.py. I'll call it practicing modules.py. And then I can say from math utilities import star. And then I can print out some even 10. Save that and run it. And there. I used it in a whole different file. And I didn't have to write any of the code there. So you can see how useful that would be in the context of a bigger software system, right? So I'm just gonna add this to the repo. Okay. What do I call this? Functions and module practice. And push it. All done. Okay, so that's it for now, and I'll see you guys in the next one. If you have, make sure if you have any questions to ask on Friday. Friday is the question period. Okay.